I'm Rachel Cronin.
And I'm Jace Thompson.
And we're in your 7th period class, and this is our chem project.
Molecular project, yeah.
Yeah.
I'll be explaining the VSEPR theory. So, VSEPR stands for valence shell electron pair repulsion. This theory explains how valence electrons of the central atom repel the other atoms bonded to that atom. It's based off the lone pairs of the central atom. Lone pairs are the bonds between the atoms. The repulsion automatically shapes the molecules. This is what creates the bond angles. Polar molecules are always asymmetrical. Water is a common example. This molecule has an electronegativity difference greater than 0.4. Non-polar molecules are symmetrical and they have an electronegativity difference of less than 0.4. Beryllium hydride. So for our model, we attach 2 hydrogens to 1 beryllium. This is our picture. So for the electronegativity difference, we got 0.5, which indicates that it's polar, but because it's symmetrical, it actually is non-polar. And it has a bond angle of 180 degrees. And it has 2 shared pairs of electrons. Molecule, I did water. And so we attached hydrogens to oxygen. This is our picture. And so for electronegativity, we got 1.4, which makes it polar, and it's asymmetrical. We got 2 unshared pairs of electrons and 2 shared pairs of electrons, and the bond angle is 104 degrees.
This is our triagonal planar model. For this example, we are using sulfur trioxide. We have 1 sulfur attached to 3 oxygens with a double bond. This would be our picture. For this example, we have 6 pairs of shared electrons and unshared electrons. The bond angle is 107 degrees. And for the electronegativity difference, we got 1.0, which would indicate that it's polar, but because the bond angles are all symmetrical, the molecule is nonpolar. This model is our trigonal pyramidal, aka our T-shaped. For this example, for ammonia, we have 1 nitrogen attached to 3 hydrogens. And this is our picture. We have 2 different bond angles, which is 90 degrees and 120. This indicates that it is polar because it's asymmetrical. And we have 3 pairs of unshared electrons and 1 pair of shared electrons. This is our tetrahedral model. For this example, we used methane, which is 1 carbon attached to 4 hydrogens. This is our picture. This molecule has a bond angle of 110. And for the electronegativity difference, we got 0.3, which indicates that it's nonpolar. And because the bond angles are the same all around, it is symmetrical. It also has 4 pairs of shared electrons.